talk about, because most of the time we have a process. We have to do a loop, because if we have a batch process that we are going to do, then we have to write a program to do a loop. So um, so that is what we want to do. So I'm going to show a process here, and then we're going to discuss how to write the program for it. What I'm going to do is I'm going to put, here's a PLC book that I got, that I'm going to PDF and then put it online. All right. So the example that we put it in the group so that you can download it and use it. So as soon as the class is finished, I'm going to PDF it and put it in the group. So I'm going to look at examples, going to show you some programming examples and things that you need to do. So if you are going to do PLC. And then I'm also going to give you today your second assignment. So first assignment do over, getting your second assignment today. I've decided that the first assignment, the next assignment you're going to do, that is going to be worth the 10% of the mark. So the one that you sent in is worth 20. This one that you're getting today is worth 30. And the third assignment that you're going to get is worth 40. I've decided that the 10% is going to be a lab test. We're just going to, because we need to know, so when you leave UTech, you can wire up the PLC. Those will form the four things that we're going to assess. We're going to mark the first assignment so that everybody has sent in the first assignment. So I'm going to mark it, and then I'm going to put it on the canvas, put your grade on the canvas side so you can see. All right. So let me just put what we want to the problem that we want to discuss up, and then we can discuss it. So give me a second to share the screen. So we can talk about the problem that we want to discuss. All right, so let us look at this charge and discharge process. So similar to what we were talking about last week, but I want to change one thing about it and write program. And then when I send you the book, you can look at the question as is and deal with it. So, all right. So you have your start and stop switch. We're only going to be using our start and stop switch. Same thing as last time. We have valve one. So you have the lower limit and the upper limit switch. S2 is a lower limit switch. S1 is the upper limit switch. You have your motor and you have your valve 2 to drain. All right. So the process is that when you press the start button, it's going to fill, and when it reaches, when it is full, you turn on the motor. I'm going to say that we're going to turn on the motor for 10 seconds. And then after the motor agitates the fluid for whatever reason, it's going to open valve 2. And when we're at S2, valve 2 is going to close. And what I'm going to want to happen is that we start back over the process. So start back over the process, and we want the process to run 5 times. So press the start button. Valve 1 opens, start to fill up the tank. When you reach switch 1, motor turn on, valve turn off, motor run for 10 seconds, valve 2 opens, the liquid empties. When it reaches switch 2, the process starts over. So we're just doing a word description of the problem. So I don't know if you understand what the process that we are saying here. Remember the Pentecostal church thing? All right. So let's go. So first thing, I'm going to be writing what are my inputs and what are my outputs. I'm just going to be making some notes while we look at the diagram. So this is the diagram that we have here. So what are my inputs? That's the first thing that we have to determine.
So start and stop.
Start and stop.
And
We are correct.
Sensor, sir.
All right. Which
the
ones?
S1 and S2.
S1 and S2.
S1 and S2. Like we said, inputs are any switches, sensors that we have in the system. All right. What about the inlet, the outputs now? What are my outputs?
V1 and V2.
V2
And the motor.
and the motor and M. So V1, V2, and M are our outputs, and start, stops, S1 and S2 are our inputs. So I'm going to give the start switch the address 0, 0, 0. Please make notes and write this down. Let us write this down so that when we start the programming, we can refer to it. Right? I'm writing it down on the board, but we just want us to focus on the diagram. So the start is 0, 0, 0, dot 0, 0. The stop I'm going to label as 0, 0, 0, dot 0, 1. S1 I'm going to label 0, 0, 0, dot 0, 2. And S2 I'll label 0, 0, 0, dot 0, 3. Remember the 0, 0, 0 means that they are inputs. And 0, 1, 0, 2, 0, 3, those are the places that we're going to put them. The outputs I'm going to label as 0, 1, 0, dot 0, 0. 0, 1, 0, dot 0, 1. And M is, so V1 is 0, 1, 0, dot 0, 0. V2 is 0, 1, 0, dot 0, 1. And M is going to be 0, 1, 0, dot 0, 2. So bear that in mind. And we say that we want the process to go 5 times. So basically we have a loop. Okay. Start is 0, 0. Stop is 0, 1. S1 is 0, 2. S2 is 0, 3. And the outputs, V1 is 0, 0. V2 is 0, 1, and V and M is 0, 2. Okay. So here is the thing that we want to do now. We want to write our statement list. All right, so let's just switch off of this little bit and then go and write our statement list or algorithm for the process. And we have to bear in mind that we want it to loop 5 times. So if you can just pin the whiteboard. So this is our rough workboard for the time being now. All right. So let's see if it would work better if I put it this way. All right. So now, so we want to write our statement list. Please pin the whiteboard. So the first thing, so yeah, the first thing, we say starts when. So this is our rough work. So when does it start? Can I get an amen?
Amen.
So when you push the start button,
When it starts, you just push.
yeah. Mhm.
What is started?
V1 starts the full.
V1. When does it end?
When it reaches S1.
When S1 is triggered. So the next part of the process starts when S1 is triggered. And what is started when S1 is triggered? It reached upper level switch. What is started? The motor. And when does it end?
After 10 seconds.
After 10 seconds. So the next part starts when 10 seconds elapse. Now when does it end?
Sir, when the water reaches S2, sorry. Wouldn't the
Sorry. So S2 is triggered. So, oh, sorry. What is started when at the 10 seconds? the ends when S2. What is started? V2. Okay. So we have our inputs and our outputs. And we have our statement list. I remember now we said that each line of the code that we're going to write is going to be a separate rung in the ladder. So now we want to, I'm going to robot each line and then write it back in ladder dash. So I know that some people writing this down. So, and like I said, it's going to be in the book that I realized that I have to PDF it and then send it to you. It's the clearest book about PLCs that I have seen. And when we finish, we're going to look at the program that they have based on the stipulation that they have. And we're going to, because there are some things there that we just want to highlight as well. But the first thing that we want to do is to say how we write a code for a process that is repeating itself. All right, so I don't know if anybody writes it down. Yeah. All right, because we put in the loop when at the after we have written the basic program, we are going to discuss. You put an addition for the looping, which is what we're going to discuss as soon as we have written the basic program. All right, but so it's a good question that you ask, because what we are saying is that you loop when you do the basic program, then you put in the loops. So the first thing that we have to do is do the basic program, and then we put in our loops. All right, so I'm going to rub out the first line and write it back. So it starts when let me put it way up here. So it starts, what did we write for start? So this is S1, and the address that I have for starts, which is 000.00. And what stops it? This is the start switch. What stops is when S1 is triggered. So this is start, and this is stop. And S1 I have here as 000.02. And what is started? What is started when we do that?
The motor.
So no, the motor. The motor here still. So that's second line.
V1, sir.
V1, valve 1. And I have that here as 010.00. And then I'm going to latch it. So when this close, the motor start, and then it's latch, and then it's only going to open when S1 trigger. All right. Second line starts when S1 is triggered, and the motor that trigger it, and ends after 10 seconds. So It starts when S1 is triggered. And it's a timer. And I should put T1 because that's what you write in the program. We latch it and we say that is the motor that is started, and I have that as 010.02. For reasons that we are going to discuss later, I will put this 000 here. And the oops, about the third line, I do say. Somebody remember what the third line said? Well, I know that whatever is here is T1 started. And what is going to be started by T1? V2. And what stops V2? S2 have here as 003, and I latch it. All right, so that's the basic program. So, but there are a few things that we have to do now. So we have to, let me deal with number one. Is a tank and the motor that is stirring in the tank, and somebody falls into the tank. What are you going to do? If the party one, just go and mix until you hear a voice say mix no more. Well, what we have to do is stop the process. Now there are different ways in which we can do that, but for now, let me just do this. So you can put the stop switch in every run. I see people who used to PLC programming cringing when I do that. But there's nothing wrong with doing it that way. Because if I do that, then wherever it is and I hit the stop switch, whatever is in operation will turn off immediately. All right, so we have the program as is now. But there's another thing. We need it to loop. We need, when we finish, we need it to start back over. So how do we achieve the looping? Well, what we do, what stops the process, whenever we want to create a loop, whatever stops the process, the very last action in the process, we use it to back at the beginning of the program to start it back. So what is the switch that triggers the end of the process? Well, it's S2. And notice something here. We have 0.002, it starts this process here. We have timer 1 stopping this, it starts this process here. So we have S2 stopping this, so we can use it to start back over the process up here. So what we normally do when we want to get a loop is that we put S2. As an OR condition. Let me say this thing down again. And I don't know why. Okay. JPS, the JPS. Flow, if any of you work at Flow, could you please complain to them, say, we have an hour on time. You stay at home issues. All right. So when we loop in, we just look at what stops the process, because if you look at, like I said, what stops the process here starts it here. What stops the process here? So 0002 stops the process here, it starts it in the next row. Okay? T1 stops the process here, it starts the next action. So S2 stops it, so it starts it. All right. So, but what we have is an indefinite loop. It's going to continue going forever. We didn't say that we wanted it to go forever. We wanted it to stop at some point. So let us do the other part of the program. Let me do first of all the timer. So that the timer is TIM number 1. You need the hashtag to say that it is decimal hashtag, and then what is the number that we put in here? How long we want the timer for? You have to check if this thing working periodically. How long we want the timer for?
10 seconds, sir.
10 seconds. So therefore, what are we going to put as our hashtag? Just check it.
100.
100. All right. So we want the timer, but the next thing that we want, and I'll put it here. I'll put it below, but it's not below. So I'm going to put it over here. We draw a line and put the next thing that we want. Is that we want it to go for 5. So now follow me now. We need something to count 5. So we need what is a counter. And the symbol for the counter is CNT. Symbol for the counter, CNT. But let me give myself some space. But there are 2 things for this run counter specifically, is that it has, every counter has 2 inputs. It has a start and it has a reset input. It has a start input and it has a reset. And the symbol for it is CNT. But here is the first thing that I want to point out when you're running the program. And it is run specific. The software does not distinguish between timers and counters in the processor. So if I have timer 1, then I can have counter 1. It's going to confuse. I have to have counter 2. If you put counter 1, and that is the most miserable, I think is that I would call it a glitch that I would ask the manufacturers to deal with. All it does is stay and look at you when you try to run the program. Just as when you write any other program, it will tell, some of the times the program will tell you, you have this error, that error. Just this will tell you when you have errors. But the cruel thing about this one is that if you do the timer 1, counter 1, it will tell you everything's fine. Let me make a sexist joke. I have a wife, I don't have a husband. You can, so everything is fine, everything is okay. You sure there's a problem? No, nothing is wrong. That's how it behaves. And then you say, but it's not working. Nothing not going on. So what is the problem? Nothing, there's no problem. So whenever you do that, that is something that you need to bear in mind. So you can give the timer and the counter the same address. If it's timer 1, counter 2. And if you have a next timer, you have to put 3, and so forth and so on. So that's the first thing. We say we want to count 5 loops. So therefore, we put number sign. And this time, we put the number sign on 5. We don't have to put a 0 on it, because it's not, all it is doing is registering every time our switch is closed or our sensor, whatever it is. So we can just put 5. So timer, you put an extra 0. If it's 10 seconds or so, but if you count in 5, you just put number sign on 5. You still have to put the number sign on 5. All right, the next thing that if you are going to count, you have to tell the counter what to count. And then you have to tell the counter, say, all right, we finish counting. We have to, when is it that we reset? So let me deal with the reset. The easiest and simplest thing, we said this is going to run a batch of 5. So you're going to go 1, 2, 3, 4, 5, lock off the system. So if you're going to run another batch, it's going to count what? Sorry, now we count 1, 2, 3, 4, 5. Get the 5, 4, 3, 2, 1. Don't count. Lock off everything. And then that's it. It's just going to stay locked off until you reset it. Now, the easiest thing to do when you're resetting, or the easiest reset button that we can use. The first default one, and then if it doesn't work, then you have to find other creative methods. But the first default one is when you press start, you reset the whole entire system. So the usual thing to do is to use as a reset. This is your reset. Is to use the start, and the start is 000.00. So the system will, whenever you press the start, the system will reset itself to begin counting again. So that is the easiest, the default that you go to every time. It don't work all the while, so you have to think about the program sometimes, but it will work in this case. All right. So now this button is the count button. What is it that you are counting? So somebody can tell me what it is that we're counting? Every time it empty out. So which one of these inputs or outputs would we count to say that the process is done? V2. That will work. So every time V2. So here what happened. So fine. What is going to happen is that if I have the program like this, it's going to say, all right, 5, 4, and you see it operating the program 5, 4, 3, 2, 1. We're done count. It count 5. 5, 4, 3, 2, 1. We're done. You have to now use the flag that is set high. And the flag that is set high that you can use is just like for timer, is when it count 10 seconds, it goes 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. All right, we finish counting 10 seconds. And set the flag high when we finish. That flag is T1. Then same thing now. There's a flag C2 that we can use. So we put it in C2. So we have this. This is the stop switch. So we're going to modify the program even more now. And we're going to put in C2. In the first row. So in other words, as soon as this V2 register that it has gone through the thing 5 times, this C2 is going to open, register the count, the flag is going to say that I've counted 5, it's going to open and turn off your system. So it's going to go through the process 1, S2, going to start the back, 2, 3, 4, 5 and the C2 is going to open. And that is that. Some people put the C2 in every run, but if you really examine the process, you see that it is not necessary. Last thing that we need to put in, and I'm just putting it in for the purpose of good programming practice, because you're not going to always use, or you're not going to use run most likely. So put in an end in your program. So this would be your program that you would use to control the process and allow it to go the 5 times. So I don't know if you have any questions. This one here. This? Huh? Oh, is the same as V. It says 0, 1. Oh, I didn't label it. Okay. T1. When do we want to start timer 1? We would want to start it when, right, when the motor come on. I was going to say when S1 register that we finish, but then remember the same problem that we talked about last week. Is the motor going to come on and start agitating the switch? So we're not going to use that. We're going to use the motor switch. So therefore this is 0, 1, 0, dot 0, 2. All right. So that is the process that is there. Hope people look at my computer screen and they go off right now, you know. Never see it here all the time. But anyhow. All right. So any other questions? I like preaching at this nice Presbyterian church. So, all right. So now.
Sir, I have a question.
Mm-hmm.
The stop button that we set an address for, we used it?
Yes. It was the one that we put in every run. Stop, stop.
Oh, okay.
Stop. We put it in every run. I was saying that some people don't put it in every run. And going forward, we're going to discuss some other little things that you can do. But for now, we're just using this that we have here as a functioning program. Like I said, experienced programmers will cringe at some of the things that are done here, but as we go, we all right. So what I want to do is go back to the program that is in, go back to the description that is in the book and make a comparison between it and some of the things that they do that you wouldn't see in this program, and explain what are some of the things that they do and some of the functions that they use that weren't used here. So you have to tell me when I can come off of this and go back to the So I'm delaying going back to the lab until after the US elections. So we'll be going, is in November after the, is when is US election again. Oh,
I think it was the first week.
huh?
I think I last week in November.
Last week? No, man. I'm not so late. I don't remember.
Sir, fourth.
Fourth, right, good.
Oh, fourth every time, yeah.
Is that what day then?
Sir, Google is telling me it's the 3rd of November, which is that Tuesday.
Okay.
So it has this year it is scheduled for the 3rd. Tuesday 3rd.
Yeah.
Okay. So the lab is first lab meeting. So when is that? This today is the 21st. Next week is the 28th. Okay. So we'll have the lab next. We'll be having the week of labs next week. We try and see what will happen for the following week. Delaying it as much as possible. All right. So let me go back to the. I can go back to the text. All right. So the thing says when you push the T1, V1 opens the reservoir, start filling up the motor. Well, it starts spinning same time as V1 starts, level goes operation sensor S1, the valve closes and the motor or the mixer stops, valve opens then, reservoir starts emptying, and when it falls below S2, the valve closes. By repeating the same cycle 4 times, a lamp that indicates the end of a cycle is activated. Pressing T1 starts a new cycle. So it goes over the thing 4 times. And then give an example program. So let me just go to the program and discuss some things that are there. Okay. So let me just check see if it's the right book because there's a whole bunch of things missing from this program that because I don't think it would work. This is the numbers, page number. All right, this program wouldn't work. So I'll have to go check something missing some things missing. Because first thing that is missing is the counter to count that it operates 4 times. But I just want to discuss a few things in the program. Let me just go to the function that is here that says DIFU 13. I'll explain. There are hundreds of functions in there. We cannot possibly discuss all of them. But there's a list that is there. And there's a one that says DIFD down. All right, so let me explain what a function like DIFU means. It means differentiate up. And this one, DIFD, means differentiate down. So differentiate up and differentiate down. I don't know if you remember when you were talking about JK flip-flop and they said the triggers on the trailing edge of the clock pulse. Anybody ever remember hearing those words? Those words used to give me nightmare because for the life of me, I couldn't understand what they were talking about. Fortunately, I went to university in the days when you could have failed a course and not worry yourself about it. It's not like that. So I was in there and I remember nobody could explain to me what trailing edge of the clock was. Well, so when you're going from 0 to 1, so you're going from off to on for anything that is called leading edge. When you're going from 0 to off to on, 0 to 1. When you're going from 1 back down to 0, 1 to 0, that is the trailing edge. So 0 to 1 is the leading edge, 1 to 0 is the trailing edge. So differentiate down means that you're going from on back to off. Now, what is that? How is that important? It is important because if you have a switch, bear in mind that this tank is filling up. Let me go back up to the tank. The S1 is a sensor that is going to go. I wish I was in the lab so we could have just hold up the level switch I'll show you. But as a matter of fact, next week we're going to go and take all of these things and carry and discuss them to talk about the practical aspects of it. But every one of these switches that we use, remember we say it's a push button switch. So it goes from off to on and then back. So what the differentiate up means is that this thing must only trigger when the thing is going from off to on. So if you think about the water filling up, when the water fill up the tank, the switch is going to turn on. All right. So the switch is going to turn on. So that is what it means. So and they give an address for the differentiate up 2001. So it says, all right, when the switch is going from off to on, differentiate up. So the switch is going up to turn on. So when it's going from off to on, activate this address. Now, the 200.01 is what is called an internal bit. It's an internal bit. Now, what an internal bit is a switch, but it's not, it's a virtual switch. It's a switch in the processor itself that you can turn on and off. It's not a physical switch like the 00, like 0 and 0 and 0, 0, 0, 0, not 0, 0, and so forth. It's an internal switch. So it is saying that when the S1, which they give address 000.05, is going from off. So if you picture it, a level switch like a tiny tank, when you empty the tiny tank, the valve is low. And then as the tank fills up, it's going to go from low to high. So it's going from 0 to 1. So it's going from off to on. And so it says when it goes from off and turn on, when it full up, and the valve which way to trigger the system, then trigger this switch here. So this thing here is called an internal bit that you can trigger. And you can use these functions to turn on internal bits. You see that they use the internal bits. Let me see where 200.01 is used. So 200.02, see it here. Although, and so that's why I said the program is incomplete. Maybe it's a good thing I'm going through this, because I think that something is missing. Maybe the page cut off or something. So I'll look and see if we get the proper one. All right, but just for the process, I want to talk about the functions. They are, you see, when you type it in there, you see tan, sine, cosine, add, subtract, multiply, divide, all different kinds of functions. So one of the functions that are important is differentiator. So when a switch is going from off to on, you can use it to trigger. You don't have to put an internal bit inside here. You can put an actual output like 010.00. But most of the time, programming practice said turn on an internal bit and use that internal bit to turn on a motor. All right. DIFD, that is differentiate down. So you're going, so think about your toilet tap again. Pull up and now it starts to empty. So the valve is going from high back down to low. So it's going from high back down to low. It's a trigger this internal bit here. We're going to use it to do something. I don't see it anywhere in the program. So that's why I said that this program is incomplete. Oh, see 20004 here. All right. So I just wanted to point out whether the program is complete or not. I just wanted to point out that there are functions that in mixing processes, and in like the garage door and all of those type of things that you will see in the book, you have DIFD and DIFU to differentiate when the thing goes up or down. And then 200, all of the 200s are internal flags or internal bits that you can trigger and use to do other things, which we'll talk about at a later time. All right. We want to put up your second assignment. For you to start thinking about and writing the program in a little bit. All right, and like I said, I'm going to look and see if I get the complete book so that I can there's several programming examples inside there for you to deal with. All right.